I'm Stephen Foskett. Welcome to Tech Field Day, coming to you November 2016 from Silicon Valley. We're here with StorageOS and the delegates that we've brought in from around the world. These are folks who specialize in servers, storage, networking, and they are intending to be part of the discussion that you're about to see. If you'd like to learn more about Tech Field Day, come to techfieldday.com. And if you'd like to see more videos like this, just go to youtube.com/techfieldday.
So, hi, my name's Chircop, and I'm the CTO and one of the founders of StorageOS. And this is...
Yeah, I'm Simon Croome. I'm the VP of Engineering and one of the founders of StorageOS.
In this session, what we're going to show is a live use case of StorageOS with a simple example of how you would deploy a containerized solution with a mixture of web systems and databases across a cluster, and to show you some of the high availability features that are built into StorageOS. For this demo, we're going to be specifically using Docker and Swarm to show our integration with those environments, and we'll be using WordPress as a simple web front end, and MySQL as a database backend. Simon, you want to start?
Okay, see that. Okay, so just to recap, my environment is a 3-node Docker cluster running on VirtualBox with Vagrant on my laptop. It has a small amount of storage presented to each virtual machine. I've set up a Docker Swarm, Docker node ls. So these are my 3 nodes in the cluster. They're all participating in one swarm, and I've got a single leader. So in this example, what I'm going to try and do is set up a MySQL database on StorageOS storage, and then I'm going to deploy 3 WordPress containers that access that database. I'll then fail over. I'll then drain all the containers from one of the storage nodes, and make sure that the database is still accessible, and that the website is still up. So we see this as a very simple deployment of a database type app, where you don't need to necessarily get involved with database replication, master-slave relationships, because the container can fail over so quickly and not lose any data. So I do need a bit of a cheat guide. So I've got my cheat guide here. So the first thing I'm going to do is create an overlay network. Docker network create, and I'll just call it WordPress. Okay, I've already done that. The second step I'm going to do is create my my database container. I'm going to cut and paste this because it's quite a beefy command. So I'm creating a Docker service with the name database. It's going to go on my WordPress overlay network, and I'm going to publish out the MySQL ports. The replicas just means I'm going to have a single node, and then the environment variables are configuring my database. The key point here is the mount option. So basically what I'm saying is that I'm going to do a volume type mount. My source name, I'm just going to change this to make sure that I'm going to call it db5. So that's the source volume name. I'm going to mount it to var lib MySQL into the container, and I'm going to use the StorageOS volume driver. I'm using Percona instead of the regular MySQL. Okay, so I've provisioned that service, Docker service. So you can see I've got my DB service. If I want to check if it's running, ps db. Okay, so it started 10 seconds ago on StorageOS 1, so the node I'm on currently. The next thing I'm going to do is just start up my my WordPress containers. So again, I'm just using a cut and pasted command, but basically we're going to call our service WP for WordPress. We're going to put it on the WordPress network, and we're going to serve it out on port 80. By specifying mode global means that it's going to run on every node in my cluster. So I should get three instances. The other key bit is just to say that I'm setting my database host to be DB. So this is basically using Docker Service Discovery and that'll resolve DB to my hostname, to the database service I created earlier. So again, if I look at my services, okay, my global WordPress, and if I look at the processes on there, okay, so I've now got 3 WordPress nodes joining. So if config eth1, so if I just launch that WordPress site on one of these nodes, whoops. So okay, so now I'm getting the WordPress installation, so that's good. So tfd12. Simon, I'll try and get through this really quickly.
So here we're effectively just bootstrapping the WordPress instance.
Come on. Very weak. Okay, there we go. Log in. Simon. Okay, great. So that's a WordPress site. I will just very quickly do a blog post. Welcome.
Think of something catchy.
I'm going to save that. Publish. Okay. You guys are the bloggers. Okay, so
Can you tell? We're not bloggers.
There you go. Welcome to FD. Okay, so now the purpose of this is just to show how easy it is to get basically a highly available site or blog. So if I go back to my console, so what we were showing before is that our database was running on StorageOS node 1. So if I do if I basically drain all the nodes on that node, hang on a sec. I need to cat vagrant swarm. So Docker node update, and I'm going to drain StorageOS 1. So if I look at my database again, so what it's done is it's shut it down on node 1. It's tried to bring it up on StorageOS 3 immediately, but basically it's saying that the volume is already mounted. And that's because within our system, we keep a distributed lock to make sure that we understand where a volume is being mounted. We don't want to have it mounted on multiple hosts at a time, otherwise we might get data corruption. So once we know that that node is really down, we'll release the lock, and you can see that StorageOS 2 has claimed the node. So that database should be up and running now. So if I go back to my website and hit refresh, sorry, I went on the node that I drained all the nodes on, including WordPress. So let me go to another node. Yeah, there we go. So that database is running on another node on the same database that we've moved from the container from one virtual machine to another, and the storage volume has followed that container, and the database is still accessible. Yeah.
So just to recap, we have done a demo with StorageOS running on tiny VMs, running on a laptop, with replication, with cluster failover, and we didn't even have to sacrifice our firstborn children to the demo gods to get that done. So yay! Okay.
Any questions on that?
So you did that with a drain from Swarm, and I'm not really a Docker guy, but that effectively means you're going to shut those down gracefully?
Yeah, I mean that's the Docker equivalent of just shutting down a node gracefully for maintenance.
What happens if that node ungracefully shut down?
So basically, there's a component within Docker which is monitoring the desired state of the cluster. So when I'd set replicas equals 1, that monitoring process will make sure that there's always at least 1 running. If I'd set replicas equals 3, it would make sure that 3 was running. So for example, if that node went offline, like just hard hung or lost power, then Docker would reschedule the container on another node, and our volume would follow along with that.
Yep.
Is there any like version control or point in time for the replication, or is it always just to the last current replication that occurred?
Well, we replicate synchronously, so
Right.
Any
So
write
there's
you do
no
to the
version
database.
control then. It's always, yeah.
Well, there is version control in terms of if you take, if you're taking snapshots, for example, or if you take point-in-time clones of the volume. We're also looking at one of the beauties of having sort of a pluggable modular architecture on the data plane is we can add some clever features later on. And one of the features we're looking to do is give you the ability to rewind and fast forwards through the consistency log or through the transaction log. So effectively, you could reverse out a few transactions if you so wanted to.
And what's the performance impact when you do take snaps?
It's not something we're testing in Angular at the moment. Snaps are something we're in the process of developing. We're still in our beta phase at this stage. Because we're handling snaps with I guess an interesting way of laying out the metadata in the storage volume. We expect you to be able to have a fair amount of snaps, sort of 10 plus easily. With limited performance degradation, so it doesn't impact memory. It doesn't impact write amplification too badly. And the idea for that is we wanted to make the snaps and the clones usable for CI/CD type environments where you're kind of building and tearing down test environments fairly rapidly, and perhaps you need snaps or clones of production data sets in your dev environments, or you want to promote large data sets that you've generated or analyzed in your dev environment into a production system.
And what's your snapshot system based on? Is it just metadata with pointers, or how is it?
At the moment, it's metadata with pointers. Yeah.
And do you have any kind of integration? So obviously, that would generate, like by default, a crash consistent snapshot. Is there any way to do application consistency if you're running anything like that? Or is it actually the fact that most people are running your container-based applications anyway, so they should be relatively resilient to the loss of an instance irrespective?
So we think there's actually a mix of people, right? So, some people are writing microservices and containers from scratch, and in which case, yes, they've designed it so that you can say, I want 5 versions of this microservice, I'm exposing these service ports, etc., etc. And if a node goes down, they're quite happy for Kubernetes or Swarm to reschedule it somewhere else. However, there are a fair amount of people that are using containers for more traditional type environments. And the reason why that is happening, from what we're seeing in many of our environments, is people have tried out containers. They've perhaps moved certain types of applications to a containerized or microservices environment, but they're still reliant on a database sitting in a traditional infrastructure. And now what we see is people trying to move some of those databases back into the new, agile, cheaper, more flexible container environment.
So you still need the consistency, obviously, at the persistent data store layer. Effect. So is there a way to trigger that within an application, or is that something the developer would need to do themselves to kind of quiesce the application before you took your snap?
At the moment, we're not doing anything special with quiescing. So, if the database has a way of quiescing or checkpointing prior to taking a snap, well, it's all API driven, so you could just call the snap through the API after you've quiesced, and that's an easy solution. Otherwise, you're reliant on crash consistency.
Are you able to replicate those snaps between volumes? So, say I've got a
volume. So the snaps are just virtual volumes in your pool of data. So they are effectively available. All the volumes and all the snaps are available on all the nodes within the volume.